So in all, today we are going to see state model analysis in control systems. So there are a lot of state model techniques are there in this control systems, especially for signal flow graph representation. The state model systems has been evaluated by using the characteristics equation of control systems. The state model representation of the signal flow graph has been derived by using the transfer function of the concerned equation. Let us see how the state model analysis has been performed in signal flow graph. So signal flow graph, it's a graphical representation of the control system. So based on the graphical representation, we can able to identify the concerned signal has been forwarded from source to destination. So while forwarding the information from source to destination, the different controls has been enabled in the signals. So those signals has been evaluated by using the looping format. The concerned loops are forwarded to the destination with the help of characteristics equations. These equations are based on input node and output node and mixed node, because input node is what are the input signals has been given to the control system is taken as an input, and the output is the final loop. All the loop will be considered into the output node, and mixed node is the cross loop with each other, so that we can able to get what are the loops are forwarded to the destination with the help of previous value. And here we are going to see the example of characteristic equation. So in this equation, they are given about how the loop has been executed. Let us see the loop, how the loop will be formed. First one is the transfer equation is upper term and lower term is denominator and numerator. The numerator and denominator can be calculated by using the above format. Let us take one is common, so minus and one is common, so that we can take it as 1 minus, so that the equation becomes 1 minus of minus. So in this denominator term, we can take it as 1 minus of minus term will be common, because we are going to mark it as a signal flow graph. So each value can be represented in this graph alone. So let us take first x1, x2 and x3. Concern differential equation is x1 dot, x2 dot and x3 dot, and u will be the input one and y will be the output signal. So all the values has been marked above the graph. So let us consider the first value minus 2 by s and minus 3 by s square and minus 1 by s cube. First we can able to mark minus 2 by s, minus 2 by s, because 1 by s for each signal, the 1 by s is for all the line. So 1 by s will be the first loop, and 1 by s is the next loop, and 1 by is the last loop. So all the loop together we can able to connect the single line which is from input node to the output node. So first is minus 2 by s, so minus 2 by s, and next one is minus 3 by s, minus 3 by s, and next one is minus 1 by s cube, minus 1 by s cube. All together we can get minus 1 by s, 1 by s, 1 by s, minus 1 into minus 1 divided by 1 s cube. So altogether we can get minus 1 by s cube. So like that, the upper value also marked by using the characteristic equation. So here we have discussed only the topic, only the value of denominator. So for numerator we can take the value for above value. So these are the possible value: 1 by s, 2 by s square and 3 by s cube. We can mark it as 1 by s, 1 by s, and 2 by s cube, 3 by s cube, 2 by s square, 3 by s cube. So straight away we can able to mark it the concerned value by the above x2 dot and x1 dot value, because it's a differentiation of concerned other value. So after the consultation work, we can get the final equation x3 dot, x2 dot or x1 dot. Altogether we can get the information like the x3 dot is what are the possible lines are there. By using x3 dot we can able to write minus 2x2 minus 2x3 minus 3x2 plus minus 1x1 plus u. and x2 dot equal to x3, x1 dot equal to x2, x1 dot, x2 dot, x3 dot equal to the concerned matrix can be framed by using the above values. So all the values are placed in the matrix so that you can get the final equation. Thank you.